Well, between, I would say, 30 to 40% that it's not a natural object, because we don't see a beautiful tail behind this object the way we see around comets.
The numbers changed, and with them, the story of an entire world tilted off balance. For months, astronomers believed this visitor from the deep beyond would drift past Mars and disappear, a silent guest in the sun's long history. Then one recalculation shifted a decimal, and everything changed. The object called 3I Atlas was not gliding. It was tightening its path, correcting its aim, bending light and gravity into a line no natural body should follow. At 87 kilometers per second, it crosses the distance between Earth and the Moon in under 80 minutes. Faster than any spacecraft humanity has ever launched. Faster than the escape of our imagination. Each hour it travels, invisible tugs from the Sun, Jupiter and Mars alter its course by mere micrometers. Tiny changes that bloom into millions of kilometers across the gulf of space. What was once a safe flyby has become a thread pulled taut across the solar system. Then came the light. Ordinary comets erupt in chaotic bursts as sunlight cracks their frozen skin. But 3I Atlas brightens and dims with mathematical precision. A flare every 17 minutes, steady as a heartbeat, unbroken for days. No natural process keeps time like that. Each pulse seems deliberate, an action, not an accident. If this rhythm is propulsion, it means the object is steering. At its present mass, roughly 10 billion tons, even a minor acceleration could shift destiny itself. A single burst increasing its speed by 10 kilometers per second, barely the thrust of a rocket launch, could send it crashing into Mars. The energy released would equal 2 million megatons of TNT, a crater 60 kilometers wide, 5 kilometers deep, enough force to erase decades of robotic exploration in a single impact. Astronomers describe its path as uncomfortably precise. Its trajectory does not wander, it adjusts. Spectral scans reveal ultraviolet spikes far beyond comet chemistry, temperatures suggesting engineered venting, not random melting. The numbers fit propulsion better than physics. If it is a comet, it is the strangest ever seen. If it is not, then it is technology. Objects from other stars are supposed to pass through like seeds on solar wind. They do not aim. They do not correct course. They do not pulse in time. 3I Atlas breaks every rule at once. Within observatories, curiosity has become unease, because behind the data lies a pattern, intent wrapped in ice. If this is technology, it is not ours. If it is nature, then nature is far cleverer than we believed. Telescopes around the world pivot to follow it. From Mauna Kea's volcanic summit to the deserts of Atacama, every eye on Earth turns upward. Each frame captured reveals the same green halo brightening, the same metronomic flicker in the void. The pulse continues, 17 minutes apart. Every time, perfect, patient, relentless. And between those beats, silence deeper than space itself. Some call it coincidence. Some call it intent. No one can call it ordinary. Already, whispers ripple through the scientific community. Could this be the first probe not built by human hands? The official statements remain calm. Press releases describe an interstellar comet of unusual activity. But inside laboratories, models collapse. Nothing about this object behaves like frozen gas and dust. It is accelerating. It is aligning. And the closer it draws, the clearer its purpose appears, though no one dares to name it aloud. In the next few weeks, 3I Atlas will reach the orbital plane of Mars. If its adjustments continue, it will pass within 2 million kilometers, a cosmic hair's breadth. Every calculation now carries an asterisk. Every prediction a warning. For centuries, humanity has searched the heavens for a message. But what if the message is not written in radio waves or mathematics? What if it arrives instead as a body of ice and metal, pulsing every 17 minutes, whispering in light rather than language. No one knows what 3I Atlas truly is, but every telescope on Earth is listening. Because somewhere between those pulses may lie the first conversation ever held between worlds. The closer the data gets, the more it refuses to agree. 3I Atlas has been scanned by every major observatory on Earth, and still no two results align. Its brightness fluctuates, its rotation speed drifts, and its density, if the numbers are even half right, makes no sense for any known comet. Each new measurement erases the last, as if the object itself is rewriting the record. To understand the mystery, astronomers begin at the beginning. Interstellar comets are not supposed to exist in such numbers. 1, maybe 2, in a human lifetime, if we are lucky. Yet in less than a decade, there have been 3. The dark shard that came before, the bright trail that followed, and now this, the one that does not behave. Somewhere in the math, the universe seems to be accelerating its surprises. Every visitor before was content to pass through. 3I Atlas, however, feels different, familiar, even. Its color, its spectral ratios, its unnatural alignment with planetary orbits, all whisper of design. But design implies a designer, and that is a sentence no agency wants to complete. Publicly, institutions speak with caution. Quiet language, small adjectives, anomalous, unusual, worthy of further observation. Privately, the tone is sharper. Inside encrypted calls and late-night messages, the words grow heavier. Non-ballistic motion, coordinated emission, possible control. It is in these private logs that the missing pieces begin to appear. Radar experiments detect echoes too clean to be rock. Not diffuse, flat, hard, reflective. Spectral graphs display metallic peaks where frozen gas should be. If true, it means 3I Atlas is not just ice and dust. It is alloy. Metal, structured, and deliberate. But facts without context are noise, and so the theories multiply. The first, fragment theory. Perhaps 3I Atlas is a shard of a shattered planet, ejected from another system. A fossil of collision, coated in ice. Possible, but improbable. The odds of such a fragment entering our system on this path are smaller than 1 in a trillion. Second, outgassing resonance. A comet made of exotic ices that vent in rhythmic bursts when heated by sunlight. It could explain the pulses, the 17-minute heartbeat. Yet no natural process keeps that rhythm. Solar heat is chaotic. It ebbs and flows with spin and surface. It does not keep time like a clock. Then, the bold theory, technology. If 3I Atlas is artificial, it may be a probe, an ancient machine launched from another star long ago, still functioning on autopilot, steering through space by controlled gas bursts. Its icy exterior could be camouflage, shielding a metallic heart beneath, a sleeping emissary, wrapped in ice. Some believe it could be a messenger, a way for an advanced civilization to send knowledge across the galaxy without faster-than-light travel. It would drift, enter new systems, refuel by sublimating its own surface and continue, an eternal traveler powered by decay and sunlight. The math works. Barely. The engineering does not, unless its creators are far beyond us. But others see something darker, a weapon of observation, a drone, scanning planetary systems for energy, habitability, or threat potential. If it finds activity, like radio signals or industrial heat, it adjusts course to investigate. Its approach toward Mars, a planet now crawling with robotic explorers, might not be coincidence. It might be curiosity or assessment. Still, even the most extraordinary theories fall before one final puzzle: the timing. Why now? The last interstellar object passed in 2017. The one before, in 2019. Now, only a few years later, another, bigger, faster, stranger. Some suggest these aren't isolated events but stages in a process. A sequence: observation, calibration, response. Theorists studying long-term celestial mechanics uncovered something startling. At its current path, 3I Atlas will reach Mars in late September, exactly as another interstellar object, codenamed R2 Swan, passes close to the Sun. Two bodies from opposite directions, arriving in the same week, within the same orbital plane. No natural model predicts such synchronicity. If they were fragments of a single origin, their trajectories should match. They don't. If they were random, their timing should differ by centuries. It doesn't. The odds are astronomical. Literally. In private memos, researchers start using a new phrase: systemic event. Not one visitor, a sequence. One that may have begun long before humans looked up. The theories now branch like tree roots. Some speak of self-replicating probes, machines that scatter across stars, each seeding another, learning, adapting, reporting back after millennia. Others imagine celestial maintenance drones, returning to the inner planets on a fixed schedule to refuel, recalibrate, or inspect. The most haunting theory of all: they are responding to us. After a century of radio broadcasts and deep space radar, the echoes may finally be coming back. And if that's true, then 3I Atlas is not the first to speak. It is the first to answer. When theory runs out, measurement begins. Every observatory that can still move its mirror turns to follow the green visitor. The goal is simple: remove interpretation, leave only data. Spectroscopy first. Light split into its atomic colors. Ordinary comets are fingerprints of water, carbon dioxide, and ammonia. 3I Atlas shows nickel, cobalt, and something else. Lines so tight they almost hum. The signal-to-noise ratio is pristine, too pristine. Next come the radar experiments. Antennas at Goldstone and Canberra bounce microwaves off its nucleus. Instead of the soft fuzz typical of ice, the returns are sharp, clean, flat planes. It behaves less like snow and more like metal plating. At first, the data team suspects error. They rerun calibration, switch frequencies, compare with the moon for control. The pattern holds. 3 distinct reflective zones rotate in sequence, like panels, each one releasing a plume of gas at exact intervals. High-speed photometry detects microflashes in the plume itself, brief flares, each lasting half a second, synchronized across telescopes half a world apart. The rhythm doesn't drift, not even by a millisecond. It is as if a hidden engine were firing, timed to an internal clock older than our calendar. The acceleration derived from these bursts is tiny, just centimeters per second, but in orbital dynamics, small numbers multiply fast. Over weeks, those centimeters compound into hundreds of kilometers. By late August, the deviation from a natural orbit has tripled. Mission planners at several agencies meet quietly. Some call it propulsion, others anomaly. Either way, the curve bends toward Mars. A private analyst describes the new trajectory in one sentence: it's not passing by the planet, it's choosing a distance. To check energy output, researchers estimate the power of each gas pulse using brightness and velocity. Each burst carries roughly 10 gigawatts of kinetic energy, enough to power an entire megacity for a few seconds. No natural jet sustains that precision or strength. Still, science demands restraint. Simulations run through supercomputers in California, Tokyo, and Geneva. They feed in dust composition, temperature gradients, sublimation rates. Every model fails. The numbers drift until the computer halts, mathematically unstable. The object refuses to stay random. And then the images arrive from orbiters near Mars. Faint streaks, 3 thin filaments of light arcing behind the main body, splitting like threads of neon. The color gradient matches carbon, cobalt, and oxygen ions. 3 energies, 1 mechanism. To engineers, that combination spells design. To physicists, it spells trouble. They calculate the combined mass at nearly 10 billion tons, moving at 87 kilometers per second. At that velocity, even dust grains would strike with the force of artillery shells. If a large fragment struck Mars, the impact could equal 2 million megaton explosions. The numbers reach the desks of planetary defense committees. The language shifts again, from anomaly to threat potential object. Emergency contingency plans, once hypothetical, now occupy real meeting rooms. Yet the fascination outweighs the fear. Because 3I Atlas is not silent. Radio telescopes pick up faint modulations in reflected solar noise. Tiny oscillations, too structured to be static, too weak to decode. A signature, maybe telemetry, maybe nothing. To test correlation, scientists compare the radio pattern to the light pulses. They match perfectly. Light and radio, two languages speaking in the same rhythm. Whatever drives this object, it is communicating, if only with itself. Across think tanks and forums, speculation ignites. Could it be mapping, scanning, charging, or waiting for alignment with something unseen? As days shorten toward equinox, one final piece of data emerges. Inferred readings reveal the body's surface temperature fluctuates ahead of each pulse, as though heat builds internally, then vents outward. A heat cycle, constant and repeatable, like breathing. For a moment, even the skeptics fall silent. In the space of a few months, 3I Atlas has gone from rock to machine, from coincidence to pattern, from silence to rhythm. And the question is no longer what it is, but why it's here now. September arrives, and with it, a silence that feels rehearsed. Public updates grow shorter. Press briefings mention routine monitoring. But behind locked screens and encrypted calls, the tone changes. The words active object now appear in official documents. Leaked data from the Mars Reconnaissance Orbiter shows a new anomaly. Faint glints in orbit above the red planet, 3 in a triangular formation. At first dismissed as cosmic rays, they reappear on consecutive passes. Stationary, reflective, organized. If they are fragments from 3I Atlas, they have already arrived. For days, analysts search for consistency in their spectra, but what emerges is worse. Each object mirrors the same spectral signature as the parent body, nickel and cobalt. Not dust, not ice, metal. By now, no one uses the word comet without hesitation. The object has defied every rule of orbital mechanics. Its tail acts like thrust, its light flickers like code, and its silence feels intentional. Then, the second twist. Inferred sensors detect a faint energy surge in the comet's core, a pulse far beyond chemical heat. Something deeper, stronger, sustained. The power signature peaks at 10 gigawatts, then stabilizes, as though an engine had awakened and then settled into idle. The numbers imply control, and control implies purpose. But purpose, in the cosmic sense, is a dangerous word. It can mean exploration. It can also mean preparation. The week of September 19th approaches, the window in which the comet is expected to cross Mars' orbit. Its pulses quicken. 17 minutes becomes 16. Each emission brighter, tighter, more focused. For planetary scientists, this is the edge of knowledge. No simulation can predict behavior beyond this point. Every telescope aims. Every detector waits. What happens next could rewrite physics or erase curiosity altogether. Then, the light fades. For several hours, no pulse, no emission, just darkness. Across observatories, heartbeats sync with data feeds. Then, at 3:42 UTC, a single flash erupts, 10 times brighter than before, and then nothing again. When the readings clear, the object has changed course. Its velocity has dropped by a fraction, Its vector shifted slightly sunward, a maneuver beyond any comet's ability. It did something. Deliberate or reactive, no one can tell. By the time the data propagates through the network, 3I Atlas has disappeared behind the sun. For the next several weeks, the object will be invisible, shielded by glare, untrackable, unknowable. That silence will be our longest pause. Because once it emerges from the far side, we will know whether it continued on its path or turned toward something else. If it returns, it may prove the first interstellar craft ever witnessed. If it does not, then it remains the greatest mystery we have ever failed to solve. Either way, the sky has already changed. For scientists, the debate will never end. Some will call it an extraordinary coincidence. Others will whisper of signals and watchers and intentions too old for language. But facts remain. It moved, it pulsed, it corrected, it vanished. And maybe that is the truest definition of intelligence, to move with purpose where others drift by chance. The coming months will bring new data. Mars orbiters will scan for debris. The James Webb Telescope will listen for returning echoes, and millions of eyes will search the dawn sky for a flicker of green light. If it reappears, it will do so silently. And every person looking up will feel the same thing, that strange mix of awe and fear reserved for the unknown. Because for the first time in history, the question is not whether we are alone. The question is whether they ever were. So the next time Mars rises over the horizon, remember that something once aimed for it. An object that behaved like a thought, moved like a choice, and left behind a riddle written in light. Perhaps it was natural. Perhaps it was designed. Perhaps the two are not opposites after all. Whatever 3I Atlas truly is, it has already done what all intelligence strives for. It made us look up and wonder again. This is Mysteries of the World. If you believe the answers are out there, stay curious, stay awake, and join us next time as we chase another question too big to ignore. Because in a universe this wide, the most terrifying silence is the one that listens back.